Hi, I'm Chelsea and I create free maths learning content for those who prefer a more visual and colourful way of learning. Sometimes I go a tad overboard on the colour, but I'm okay with that. I'm also trying to add a bit of a female perspective to maths learning because I'm a bit sick and tired of it always being about old dead dudes. So this series is aimed at students aged 11 to 16. If you're older than 16, then you might prefer the harder maths content. Just head to my Instagram page. I post all of my mathematical learning materials on there, as well as a bit of art and some stuff to do with my career as a data scientist. Okay, let's get started.
Ratios are everywhere. They often describe how much of one thing there is relative to another thing, and they tend to be written in this form, where X is one thing and Y is some other thing. So as an example, when making a glass of dilute juice, the recipe might be 1 part juice to 3 parts water. This as a ratio would be written like this. What this ratio actually tells us is, if you were to pour 10 millilitres of juice, you would have to pour 3 times that amount of water. So 10 millilitres times by 3 equals 30 millilitres water. And again, if you were to pour 50 millilitres of juice, you would look back at your ratio and go, okay, that means I have to pour 50 times by 3, which is equal to 150 millilitres of water. Going from the opposite angle, if you were to pour 300 millilitres of water, this ratio would tell you that, you need to pour 300 millilitres divided by 3, which equals 100 millilitres of juice. So maybe you can see why ratios are helpful. This ratio for making juice is a bit like a recipe, but it's a recipe that doesn't depend on a final amount. i.e. this recipe can be used for making a 40 millilitre glass of juice as well as a 200 millilitre glass of juice. It's like a universal key to make or describe things relative to one another. Let's have a look at some examples. If you're told that a smoothie contains strawberries and raspberries in the ratio 2 to 3, these are the things that you should think about and then know about this smoothie. Firstly, there are 5 parts to the smoothie. This 5 is calculated from adding up the numbers in the ratio. Second, 2/5 of the parts of that smoothie are strawberries, or 40% of the parts of the smoothie are strawberries. The 2 comes from the side of the ratio that is talking about the strawberries. You know this part is talking about strawberries because strawberries comes first in the sentence and strawberries comes first in the ratio. The 5 comes from the whole parts. So you take the 2 for the strawberries, you take the whole parts and you say, okay, 2/5 of the parts of the smoothie are strawberries. And 3/5 or 60% of the parts of the smoothie are raspberries. Now, in some questions, we're often told what a part is worth, i.e. a part might be a unit such as grams or millilitres. So let's have a look at one of these examples. In this question, our ratio contains units. We're told in a tub of Jen and Berries, cookie dough ice cream, for every 20 grams of cookie dough, there is 70 grams of ice cream. So here we've got a unit. In this question, we're asked how much cookie dough and ice cream are therefore contained in a 450 gram tub. Well, just like before, you should ask yourself, well, what can I learn from this ratio? So just like in the example above, we know that the ice cream is made up of 20 plus 70 equals 90 grams of parts. 20 grams divided by 90 grams, which simplifies to 2/9, of the ice cream is made up of cookie dough. In order to find out how much cookie dough is in this specific tub, we need to times this fraction by the tub's weight and we get 100 grams. Therefore, in this tub, we have 100 grams of cookie dough. Similarly, 70 grams divided by 90 grams, which simplifies to 7/9, of the ice cream is made up of actual ice cream. In order to find out how much of the 450 gram tub is made up of ice cream, we times this fraction by 450 grams and we get 350. Therefore, in this tub of ice cream, 100 grams are made up of cookie dough and 350 grams of it are made up of actual ice cream. Now, in this example that we've just gone through, our ratio contains these numbers, 20 and 70, which are quite simple numbers. However, they could be simpler. Just like with equations, ratios can be simplified, i.e. what you do to one side, you do to the other. So for instance, in this ratio, we could have divided both sides by 10 and therefore had the ratio 2 grams to 7 grams. If you were to take that ratio and work through all these parts again, you would see that you get to the same answer. In fact, you could do this now if you like. With some questions, you might find that you want to simplify your ratios before using them in any calculations. So let's go over some ways that ratios can be simplified, or you might get asked questions about to simplify. The first way to simplify a ratio that we're going to talk about is reducing a ratio to its simplest form. I kind of just went over it in this example. It is when your ratio has a common factor, meaning you can divide through by that factor. So for instance, if you had the question, write the ratio 18:4 in its simplest form, you would look at the ratio and say, okay, is there a number that divides both 18 and 4? Well, 18 is 9 times by 2 and 4 is 2 times by 2. Therefore, you could divide both sides by 2 and therefore reduce the ratio to its simplest form. And doing this, the ratio becomes 9:2. Another way to simplify ratios is to get rid of fractions or decimals. In general, if your ratio contains fractions, you want to times by the denominator, i.e. the number on the bottom, in order to remove the fraction. When it's decimals, you generally want to times by some multiple of 10, i.e. you're moving the decimal place along, so you're getting rid of the decimal. In this example, we're asked to simplify the ratio 3/5 to 1/10. Now, if we were to times both sides by 5, that would remove the fraction from the left-hand side, but you would still have the fraction on the right-hand side. However, if we were to times both sides by 10, that would remove the fraction on the left as well as the right. Timesing both sides by 10 would give 30/5 to 10/10, which reduces to 6:1. Another way to simplify ratios is when they have mixed units. So here in this example, we're asked to reduce the ratio 0.5 litres to 10 millilitres to its simplest form. First thing I like to do is write out the units. So 1 L is 1 litre and 1 ml is 1 millilitre. Next thing I write out is the conversion. So 1 litre is equal to 1000 millilitres. Using this relationship, we can convert the litres to millilitres. So we can take this 1 litre and times it by 0.5, which will give this left-hand side of the ratio. But remember, using this conversion, what you do to one side, you have to do to the other. So if we times this side by 0.5, we have to times this side by 0.5. Therefore, we get 0.5 litres is equal to 500 millilitres. So this left-hand side can be replaced to 500 millilitres. Therefore, our ratio simplifies to 500 millilitres to 10 millilitres. Hopefully you can see that this can be simplified further. We can divide both sides by 10, i.e. get rid of this 0, get rid of this 0. So we get the ratio as 50 millilitres to 1 millilitre. In general, with these kind of questions, you want to convert the ratio to the smallest unit, i.e. we went from litres to millilitres rather than millilitres to litres. Okay, that is the end of this worksheet. Here is a set of questions that I've put together. The answers for these are given on the answer page, which is on my Instagram account. The link to this is in the description box below, so be sure to try out these questions and then go along to there to see if your answers and workings compare. Thank you very much for watching.